Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the fundamental theorem of algebra, the result that guarantees every polynomial equation has exactly as many roots as its degree. Let's begin. The fundamental theorem of algebra states that every polynomial equation of degree n, with complex coefficients, and n greater than or equal to 1 has at least one root, in the set of complex numbers. Combining this genuinely powerful result with the factor theorem, applied repeatedly, leads directly to an even stronger, more useful conclusion: every polynomial equation of degree n has exactly n roots, when those roots are counted with their appropriate multiplicity. This specifically means the complex numbers are genuinely algebraically closed, unlike the real numbers, where an equation like x squared plus 1 equals 0 has genuinely no solution at all. Every single polynomial equation is guaranteed to be completely solvable once you allow complex number solutions. Counting roots with multiplicity genuinely means that if a specific factor, like x minus 2, appears 3 separate times in the fully factored polynomial, that root, x equals 2, is counted 3 separate times toward the total or n roots, even though there's only one genuinely distinct numerical value. A genuinely important fuckly used companion result applies specifically when the polynomial's coefficients are all real numbers. In that specific case, complex roots always occur in conjugate pairs, meaning, if a plus bi is a root, then its conjugate, a minus bi, must also genuinely be a root of that exact same polynomial. This direct consequence means a polynomial with real coefficients and ODD degree must have at least one genuinely real root, since complex roots always pair up evenly, leaving at least one root that simply cannot be complex. A genuinely classic JEE application uses the conjugate pairing rule directly. If you are told a cubic equation with real coefficients has a specific complex root like 2 plus 3i, you immediately know 2 minus 3i is genuinely also a root, and since it's degree 3, an odd degree, the remaining root must genuinely be real. This lets you find the entire equation using sum and product of roots relationships without doing any additional complicated work. A frequently tested trap involves genuinely forgetting to count multiplicity correctly. A question might ask, how many distinct roots does a given polynomial have, versus how many roots does it have counted with multiplicity? These can genuinely give completely different numerical answers if any factor is repeated. Also remember, the conjugate pairing rule specifically requires real coefficients. If a polynomial genuinely has complex coefficients, like ix squared plus x plus 1 equals 0, complex roots do not need to pair up as conjugates at all. Let's recap. The fundamental theorem of algebra guarantees every degree n polynomial equation has exactly n complex roots, counted with multiplicity, making the complex numbers algebraically closed. For polynomials with real coefficients, specifically complex roots always occur in conjugate pairs, which means odd degree real polynomials always have at least one real root. Using this conjugate pairing rule to quickly find missing roots is one of the most frequently tested JEE applications of this theorem. That's the fundamental theorem of algebra. Keep the conjugate pairing rule for real coefficient polynomials sharp. It's the fastest way to find missing roots on the exam. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.